I'm sure many of you would have celebrated Holi, the festival of colors. Me, I'm not a fan of this festival as I hate getting myself or my clothes dirty, so I stay away from the hooligans. You could say I practice social distancing and quarantine a long time due to this festival. But I'm sure many of you are sporting various shades of red and purple and blue and green still. So keeping in trend, we present you a snippet on colors. But it's a bit misleading. Welcome to the true colors of color. So, how many colors has a rainbow? I don't think you would need any time to answer this question. 7. Even without me asking you, you would be able to give me the 7 colors in order which they appear. Violet, indigo, blue, green, yellow, orange and red, or Vibja for short. Even though this has become what we call common knowledge, there are a lot of complications when it comes to the colors of the rainbow and colors in general. Let us start with complication number 1. In the spectrum of colors starting from violet to red, how many of you can correctly identify the second color, indigo? Thinking of the famous airline and its logo may help to a certain extent, but is this the indigo that you have seen in the previous picture? And if you asked to think about an indigo colored sari, are you able to picturize it as easily as you would with any other color? Say a red sari? It was Isaac Newton who first split the white light into its 7 components. You must have all heard of the famous prism experiment where he let white light from the sun through a prism onto a wall and the prism split the white light into its individual colors. So this is how the spectrum looks like. The people who think that the rainbow has 7 colors, please look at the spectrum and identify the 7 colors. Where does one color end and the other start? Can you identify the precise spots where violet ends and indigo starts, or where yellow ends and orange starts? Do you see any kind of boundary between the colors here? Think of the times you have seen a rainbow. Were there any demarcating boundary there too? It's impossible. So where did we get this notion that white light is composed of 7 colors? The answer to this is a bit novel. The notion that a rainbow has 7 colors is not a scientific fact. Instead, it has historic roots. That idea is just one of Newton's fancy. He just saw 7 colors, which was due to his cognitive bias. 7 was a magical number those days. There were 7 notes in music, 7 planets, and there were 7 days in a week, and so on. So when he looked at the spectrum, he just assumed that there were 7 colors. That is how rainbows ended up getting 7 colors. In reality, there are countless other colors within this spectrum. Now, which color did Newton choose as indigo? In Newtonian times, people used a deep blue colored dye called indigo blue. So what Newton meant as indigo was indigo blue. That color is actually blue in color. So what Newton called indigo, today we call it blue. So what color did Newton call as blue? That color is today called as cyan. So the problem here is that since there is no clear demarcation, people can have different notions for the same color. Your blue might not be my blue. Because we all belong to the species called Homo sapiens and 99% of our genes are the same, our ability to see the same colors are hardwired in us. That is why we can make another person understand about the color that we are referring to. You need to keep in mind that it is not 100% accurate. It is an approximation. So as per modern standards, the colors in a rainbow has to be violet, blue, cyan. green, yellow, orange and red. So the total number of colors in a spectrum is different from Newton's concept, and the colors are also different. So how do we identify colors? When light falls on an object and it reflects it, the electromagnetic radiation falls on our eyes. Among the different wavelengths of light, our eyes can perceive three main kinds of wavelengths. Your brain mixes these three different wavelengths and causes different color visions. These three wavelengths are what we call as red, blue and green, the primary colors. Until it reaches your brain, these three colors are actually just three different wavelengths of light. Color is actually an illusion created by your brain. Remove the illusion and the colors turns out to be just wavelengths of an electromagnetic radiation of different wavelengths. We have three different kinds of corn cells which create the different colors that we see around us. We call this trichromatic vision. So colors are not a property of an object, but it is an illusion or an experience created by your brain. So what color is an apple? Red? How do you say it is red? You may all remember the sensation that a dress caused on social media. Many saw this dress as blue and some saw it as golden, whereas the actual dress was black and white. But today, thanks to science, we have machines that can measure the radiation coming from various areas of an object and can clearly say what color it is. So clearly, the scientists are fighting over the dress. What about these shoes? Some see it green and grey and some see it pink and white. So how do we see colors? For a painter, for instance, a color is just a number, or rather, we have categorized each color by a unique number. But what about us? When we see an apple and I ask you for the color, you would normally say, that apple is red. Okay, let me hear you say it. Very good. Now the very construction of the sentence implies that you are describing an intrinsic property of that apple. So the apple possesses that color, right? Basically, as white light falls on the apple reflects the red light and that reaches your eyes. Now imagine a red apple placed on a blue plate. So why is this plate blue? You are seeing two different objects using the same eyes with the same white light that is falling on them, but one is blue and the other is red. Now here is the misconception about the color. So here is the white light coming upon the apple. The only reason it is red is because it reflected, or rather rejected, the red color. It absorbed all the other colors in the spectrum. You call it red because that is not what it is. That is what it sent back to you. There is no red in and among that apple because it sent all of the red back to you. So the language that we use when we say that the apple is red is logically flawed given what I am telling you about light. The apple is actually all the other colors in the spectrum. The violet, blue, cyan, green, yellow and orange. That is what it is. And what it isn't is red. We can just refer colloquially that a red object is red. We can just say that. But if you go to the surface molecules of that apple, there is no red there. Don't believe me? If you actually had a light which contained no red in it, say an ultraviolet lamp or even those old sodium vapor lamps, I don't know if they still have it in our country. I'm sure some villages would still have them. So if you took your red apple and kept it under that lamp, what color would it be? It can't be red because the light source does not contain red. Any guesses? The apple will be black. That is because it cannot reflect back any red as there isn't any, and it absorbs all the colors, which makes it black. Black is the absence of all colors. White contains all colors, whereas black has none. This is confusing to anyone who paints as mixing all colors gives you black while painting. But light works differently. So the blue plate under the same lamp might appear blue and the yellow bird would definitely look yellow, but the apple would appear black. Okay, still don't believe me? Here is an experiment that you can try for yourself. Get a red light, a 0-watt bulb or one of those latest LED lamps which you can turn into a zillion colors, and set it to red. Make sure there is no other light in the room and place a Coca-Cola can on the table. What would you see? Would you be able to know if it is a Coca-Cola can through the markings? Let us know what you think in the comment section. What color would the writings on the Coke can be in a room filled with red light? Let us see if you have got the idea about colors. Now coming to the universe, we see the universe in a wide array of colors. Many of you would have put these as wallpapers on your computer or mobiles. Take a look at these pictures. These are all pictures of a celestial region called as Nebulae. These are basically stellar factories. That is where new stars are formed. So now imagine, instead of looking at the nebulae through a telescope, what if you stood in the middle of this nebulae and looked around? What would you expect to see? Do you picturize a dramatic visual like what you have normally seen in films? The hero and the heroine are dancing and around them are a multitude of different colors worn by the dancers? Then let me break that myth. That picture is completely wrong. If you stood in the middle of a nebula, the vision that you would be seeing is not that. Not even close by any standards. Instead, if you looked around, you are not going to see anything. Or rather, you would see nothing. Even though you would see the nebulae as a sort of dense cloud or a smoke screen, in reality, nebulae are very sparse or uncrowded. If you actually take up 1 centimeter by 1 centimeter cube from that nebula, you might find around 100 to 1,000,000 molecules max. Remember, 1,000,000 has only 6 zeros. These may be molecules of hydrogen, oxygen or sulfur. Let us compare this with our air. The air that we are breathing in currently contains 10 raised to 19 gaseous molecules in the same 1 centimeter by 1 centimeter cube. Compare 6 zeros with 19. The most ultra high vacuum that we have been able to create is 10 raised to minus 6 millibars. Even that has only 10 zeros. So nebulae are regions which are very less dense. Hence, even if you take a nebulae the size of the Earth, it would weigh around 2 to 3 kilos only. So if you stood in the middle of a nebula, you would not see anything, similar to the way you are not able to see the air around you. So how do you see these nebulae as colorful clouds? That is because these are hundreds or thousands of light years away and they are spread over hundreds of light years from left to right. And when you look through a telescope, you can see this great expanse in your field of vision, and your eyes along with the telescope compresses this huge expanse into your field of vision. As you go closer, the light spreads away and it starts to lose its density. When you try to zoom using a binoculars, for instance, as you try to zoom in, you will see that the object starts to fade away after you zoom maximum. That is because the light spreads away from the object, causing it to appear fuzzy. So as you go towards these nebulae, it starts to fade away until you see absolutely nothing at all. So what about the colors of the nebulae? As we mentioned, there are many molecules in this cloud type formation. These molecules inside the nebulae comprises of various molecules, mainly hydrogen, oxygen and sulfur. As I mentioned, nebulae are stellar factories. As new stars gets formed there due to gravitational collapse, they release a lot of energy. These excites the molecules of elements present there and they get into a highly energized state. But they can't stay in that state for long. they finally try to come back to their original state whilst releasing the extra energy. This is in form of radiation, and this is what we get to see. Also, one interesting point to note is that they don't release the bright colors that we see in pictures of nebulae. They are all computer simulated images. So one may ask, so are these fake pictures? No. The fact of the matter is that these images are taken by telescopes with a large aperture. As you would know, the bigger the aperture, the more light gets captured into the lens. So telescopes with bigger apertures like the Large Binocular Telescope in Arizona, US can capture even minute light coming from these nebulae and take photographs of it. So these are long exposure shots. So the lenses of these telescopes remain open for a long period of time, maximizing the light entering into it. So they are able to capture these beautiful images for us to use as wallpapers. One more thing. People who may be interested in astronomy, please don't run to the nearest shop to buy a telescope to see these grand sights. The normal telescopes that you get to buy in stores do not have the ability to spot these gas clouds. Also, most of these colors that you see are false colored images. These images are not taken for us to be put as wallpapers. Astronomers studying these nebulae need to study them better. So they assign some colors to the various elements like hydrogen and sulfur and get composited as the final picture. They need to know what these objects are, and since they cannot go there, they use colors to understand what lies in there. So thus we come to the end of this video, which talked about various misconceptions that we have about color. We hope you enjoyed this snippet. We will be back with more very soon. Till then, it's bye-bye from Pale Blue Thoughts.